So welcome to the Node.js N-API Team meeting for September 16, 2019. We'll follow our standard agenda, which is to go through the things we've tagged for the milestone. Before we do that, does anybody have any announcements or other sort of information they want to share? If not, then I'm going to go and share that screen. So the first one we have is building add-ons with CMake. Now, I think this was, right, so this one I tagged, so there's basically this is some discussion in Node.js about using CMake. And I remember, Jim, you mentioned that you'd done some work to help on that front, but I didn't remember the details. So we've been kind of deferring until you were back to bring us up to date. And
I will take a look at this. I added features to pre-build to support CMake.
Okay.
So I'm anxious to look at this thread and see what's going on here. Okay.
So yeah, so if you can do that, sort of, if there's something else that needs to be, we need to think or talk about, but it sounded like it was kind of like asking for what you'd done some work about was, you know, packing the binaries for all the platforms and stuff like that.
Right. Okay, I will take a look at this.
Okay, sounds good.
Can I say?
Yep.
About this, my opinion is that we need to see if what is already exists, like CMake-JS is good, and we can update, so open a request to this module, or maybe we need to create our custom builder that help to build a native add-on with CMake. So the idea is to evaluate what we have now, and if it's good, we can extend what we have.
So what I'm going to, okay, so maybe I already did that. So let's see, I just want to see. So this is here. So Nicola, I'm going to take some notes on what you just said. We should look at existing solutions like, it was CMake.js?
Yeah, CMake-JS, yes.
And see if we need, they need any updates to support Node add-on API.
Yeah,
that kind of.
I think that the problem is only for Node add-on API.
Okay.
The work I did in pre-build was based on CMake.js, and so.
And maybe we can move some ideas that you already some that you already did from directly in CMake.js. So all that module that will depend on CMake.js will be okay.
Yeah.
So, and we will have only a single point of failure in the future, and we only need to change one module to maybe fix something.
Yeah, if I recall correctly, CMake.js is pretty generic, and so I did not need to do anything to CMake.js other than just document what configuration information you want to have in your CMake files.
Yeah, and I don't remember well, but maybe it's only a question of documenting on how to do something.
Right. And so what I can do is on this particular issue, I can link to the documentation I put on pre-build to see if that might be applicable here.
Okay.
Okay, so I'm going to say Jim will review issue and let us know what he thinks we should do. Add doc he created to issue 2. That sound right?
Yeah.
Okay. Okay, that sounds good. Any more discussion, comments on that one before we move on? Okay, N-API WASM bindings. So this is right. I don't think there's been any. Go ahead. Yeah.
I saw that now we have a fork of the Node.js official repo, and but we don't know where at one point is all this project.
Right. Was there actually, because there is a WASM, there was a new, but I think it might have been for something else. There was a WASI, but I think this is to implement WASI in Node as opposed to.
Okay. I don't know if there is a WASM.
Yeah, no.
Okay,
so I think
sorry, I confused the two things.
So but we should follow up. I've been meaning to follow up with pretty sure that's right, with Ali as well on that. Okay, so we'll see if we can get an update on that one, but I don't have any new news unless anybody else does. Okay, what should go into N-API 5? I don't know, Gabriel is still just working through the versions.
Yep, basically I need to backport the matrix update, which landed on master, and
Okay.
put a replace me in all the right places. But yeah, it's status quo as far as I can tell.
Okay. I mean, the matrix update is like a doc, so it's good, but not as critical as the others, right?
Yeah.
I guess, is this current, is this status here the current one, or is?
It's yeah, last time I checked, yeah, I haven't updated this in a while. I mean, like a couple of days, but I checked on it last week.
Okay. But the V8, because the last update was July 8th there.
Yes.
Okay.
So basically, yeah, we're missing everything from version 8 and the optional DSFN callback from version 10.
Okay. In terms of, you've got PRs out there, but they just haven't landed, right?
Yeah. Those are the numbers. Yeah.
Yeah. Okay. Right. Oh, those are the actual PRs. Yeah. Okay. So
yeah,
when we get
can you hover over the last one for version 10? Because if that one's closed, then maybe it's still open.
Yeah. Okay. Well, I know Bethany was busy with some things. So she should be getting back to builds, I think, this kind of timeline now. So hopefully they'll start to be progress.
Yeah, I think for version 8, at least one of them doesn't have approvals. This one's approved, so this should be ready to go. But I think one of them is still missing. Yeah, I think this one, because it doesn't say approved by anyone.
Okay. Is there anything different about this versus the other backports?
I don't think so. It's the same as the other ones.
And date was, It was experimental at some point, right? Like in terms of it required a certain V8 version. I'm just trying to remember. That would be the only other thing. But obviously you've tested it and it works, right? So.
I believe so, yeah.
Yeah,
Or it should
okay.
be good to go.
Okay. Okay, I will try and take a look at that one then so that we get at least an approval.
Yeah.
Okay. Let's check the other one then.
Yeah.
Okay.
This
Okay.
one has two.
Okay. I'll look at that one. Good to know.
Work our way through the list.
Sorry, say that again.
It's just got to work our way through the list. That's all.
Yep. Okay. Good. Just checking in. Additional async worker variants.
We have a paragraph that is a draft
Right.
now on the Node API.
That one.
Implement async progress worker.
Right. Yes. Okay.
Yeah.
Right. So I'm just going to copy that as a. PR to add async pro. Okay, so there's some progress on that one. Okay, so there's that one. Basically, it's a work in progress. I think still, is that right?
He today he made some push, so
okay.
We need to review.
Okay, sounds good. Okay, so we're making progress on that one. That's good. The workshop. So I know, Jim, you were starting to work on that.
Yeah, I've not got a lot done the last couple of weeks, but
okay.
I have made my travel arrangements, so I do expect to be at the workshop.
Excellent. That's good.
Yep.
Good news.
Yeah.
So I think ideally all four of us at least will be there, so that's good.
Yeah.
I don't know, Kevin, if you had any thoughts of going to the Node+JS Interactive?
No, I'm not going to be there, unfortunately.
Okay. There is the travel fund if you needed travel funding, just to keep in mind. But okay. Okay, so yeah. I'm just looking at if there's any other recent.
Yeah, I have some.
Sorry, go ahead.
Yeah, the issue 346. I investigate N-API helping to avoid.
Yep, I think was that in the list. Was there then this one?
Yeah,
346. Yeah, okay. Yep.
Yeah. So there is a team of Neon that are working on provide the binding to N-API, and they asked for something about these two macro node N-API module init. Because the problem is that they won't know if N-API underscore module type is stable.
So where is that defined?
It's in node underscore API.cc, I think, or a.h.
Node under. Okay.
Yeah, .h. Node underscore API.h.
Right. So which one? The
dirty line. The number of line is dirty. The no NAPI module structure.
Sorry, say that again.
So they asked if this structure NAPI underscore module that is in the line.
Right, this one.
No, the structure.
No.
So the
this one.
Yeah, if it's a type that could be considered ABI stable.
Yeah.
Because they want. Okay.
I think the answer is yes, but Gabriel, correct me if I'm wrong on that one, but
yeah, I also think yes. There's it hasn't changed since we introduced an API. So I mean, yeah, like modules, version 6 modules should still load, but we should sort of have some testing about that, like where you like build like the tests on one version of Node and then you run it on another version of Node without rebuilding. We should really have that, but that takes a huge
yeah, that's
effort.
more effort, but that's, I mean, it's the I guess since it's in .h, we expect the answer to be yes. I'm just wondering if there's any reason why it would appear that it wouldn't be.
The reason because they asked this is that they want implement the function to initialize the module by itself. So they don't want to use the C macro.
Right, but I think the answer is it needs to be, right, because otherwise, yeah. Like they don't want to use NAPI module or NAPI module X, right?
Yeah.
But I think that the reality is that the C function, which does the register, is what we actually export.
Well, no. The NAPI module register is the function that needs to be called from the library constructor to register the module. And there's actually an alternative module registration process which we introduced I don't know by a while back with Ben, and that's to have like a special symbol. So you have like a NAPI underscore register module underscore 1, and then that's like NAPI module version 1, and so it looks for that special symbol, and that's it. So and that also allows for multiple registration. Well, I know that meanwhile we have multiple registration even for structure-based modules, but the cleanest way to load the module is to just define that special symbol with NAPI module export, and that's what NAPI module init does for you. If you use NAPI module init, it doesn't create any structure. It just creates the special symbol, and it allows you to fill in the body of what should be done. So I think NAPI module init is the safest way to go, because all it does is declare a symbol that has a certain name, and that name is API stable in the sense that it will only become incompatible if ever we define like a version 2 of an N-API module, and even then we can fall back. So we can do mitigations, but for now we don't have any such need.
Right, but I guess they don't want to use the macro, and their question is, what should they do without using the macro that's considered stable, right?
Yeah, so I mean, basically they should expand the macro by hand.
Right.
That's all I can say. So basically, if you do like a NAPI value, a NAPI module export, NAPI register module V1, I guess. Where's this NAPI module version defined? It must be at the top somewhere. No, you wouldn't find that. It would be like NAPI module version. Oh, there it is. There it was at the top there.
Yeah, it's yeah.
Yeah, no, NAPI
Line
module.
40.
Define NAPI module
Oh, yeah,
version.
there it
It's
is.
one.
One, yeah. So basically, so you have like you declare that function NAPI register module v1, and then a bracket NAPI env, comma NAPI value exports. That's it. That's all you have to do is just declare that function, and you're done. And that function would be called multiple times from multiple threads, however many worker threads you have. All the benefits and restrictions of having like context-aware modules applies, and that's it. So if they don't want to use the macros, all they need to do is define that function, NAPI register module v1. That's it.
Okay.
And that is the module entry point, and it will load. Now, I don't remember how far back we've ported this special this special symbol thing. Like I'm pretty sure it's in 10. Well, why don't I double check?
Yeah, I think that's worth checking.
Let's see how far back it goes. Okay, see node 2 is branch. Okay, check out the temp.x staging. Oh, for crying out loud! I have on safety. Let me find.
Excuse me.
Well, okay, I can't use my local copy because there's stuff going on, but HTTPS GitHub, Node.js, Node, Lob, v temp.x staging, circ, JS native API. No, sorry, Node API.h. Okay, NAPI module init. Yeah, okay, so NAPI module init exists in version 10. Now let's see v8.x staging. NAPI module. No, okay, we don't have it in we don't have it in 8, but we have it in 10. So let me see v8.x staging src node API CC if I'm not mistaken. No. Node.cc. Yeah, find DL open. Okay, DL open on version 8. DL open on version 8. Okay. Yeah, I don't believe it falls back to the special symbol. Okay, so we don't have the special symbol support on 8, but we do have it on 10 and 12 and everyone beyond that.
Right.
So that's the situation. So yeah, I mean the structure is definitely ABI stable if they want to go with the structure. And the special symbol is also API stable, and it goes back to version 10. So it's up to them which one they want to use. I would prefer the special symbol because that's more it's much simpler, and they're not relying on any structure. Symbols are very unlikely to change, less likely than structures. So you know it depends on what versions of Node they wish to support, but those are their options.
Right. In terms of the symbol, though, it seems like it would be worth potentially adding some, I guess like maybe what they're asking is like that we add to the documentation that says, you know, if you're implementing in a different language, this is the symbol you should export.
Yeah.
Because looking at this file, it's you can probably, I'm sure you can figure it out, but it's not obvious.
Yeah. I forget how extensively we documented this, but docs 12 add-ons. Okay, NAPI module init. Oh boy, I forget where we documented all this stuff.
Well,
There's a Oh, there's a guide, I think, somewhere. Where did we put that? I
Well, we
mean,
have.
like the stuff that I mentioned in my blog post, that's what I'm talking about here. Maybe it's in like regular add-ons. Context-aware add-on.
Module init. So this is, we have NAPI module init in the examples.
I guess we don't really document how those macros work, only that they exist and they should be used.
Right, exactly. In fact, it's really just the, that's where like I could see if it's a, like it's fairly obvious for the, you know, this one, the NAPI module, or is it NAPI? Like the one that uses NAPI mod, the structure is pretty obvious. Like NAPI module register, it's a C function. If you expose that C function and use that structure, you don't need to. You don't need to use the macro, right?
No, it's actually the other way around, right? Like you need to create the structure. You need to create the structure like global static, and then you need to create a library constructor, and inside the library constructor you call NAPI module register, and you pass that structure.
Right.
So
but like you're calling
process.
an exported C function just like the other NAPI calls, right?
Well, it's an N-API. Like NAPI module register is an N-API like any other N-API.
Right, exactly.
But unlike
yeah,
API, it doesn't take an API because it's a lower level API still.
Right. But that one seems like it's more obvious that you could use it that way. The other one is not obvious, right?
It's the older mechanism. Well, I mean, you know, a lot of add-on systems are based on special symbols, so it's not out of the ordinary. It's just a newer.
I'm not saying it's out of the ordinary. I'm just saying that, like, I can see where it wouldn't be obvious that that's one of the ways you could, if you're not using the macros, what you would do, right? So adding something into the docs that says, probably something that covers both of them. Because we have NAPI module register in those docs.
I don't think so.
I guess we don't even have NAPI module register there.
Yeah.
That's probably worth an addition.
Document. Yeah. Yeah. So I guess in general the way Node.js loads modules bears documentation. Especially if people are going to start writing add-ons using languages other than C, because I mean Node.js is sort of honed for C and C++ add-ons, but if add-ons are going to be from other languages, we need to specify the binary interface. We need to better document the binary interface.
Right. Okay. So I think that's the action that makes sense.
Yeah.
So, I could add.
But in terms of their.
Go ahead.
In terms of their question as to whether it's API stable, absolutely, it is definitely API stable. The only thing it's lacking is documentation, but API stability it has as much as it can.
Right. So I can take the action to add to the doc to add NAPI module register. The only thing would be but maybe your suggestion is if they're not worried about 8, it would be better to go with the other approach.
Yes, it is simpler. It is much simpler because it doesn't involve a structure. They need to do nothing except write a function that has a certain name, and that's it. And so, you know, they're not relying on a structure that may change in the future.
Right.
The only thing that may change in the future is that Node.js for some reason no longer looks for a symbol by that name. But that is also very unlikely because we wish to remain as compatible as possible.
Although the structure is not like, I mean, we wouldn't change the structure that N-API module register takes. If we did, we'd have to maybe make N-API module register 2 with a new structure and still support the old one.
Yeah.
Right,
I mean,
and then we have Sorry, go ahead.
I was just going to say we have some leeway in the structure because we do have the versioning and we do have some reserved words there. So we can go within the structure without having to add a symbol. Yeah, we could just add another symbol, and at that point it would just be the same as just having the add-on export another symbol. So it becomes pretty much equivalent at that point. Whether you actually there is one other reason why you would want to go with a special symbol, and that's the fact that library constructors are not necessarily always available. Like, for example, when I was doing JavaScript doesn't have library constructors by default.
Right.
It actually needed to be implemented as a feature of the bare bones C library that they were using. Whereas exporting symbols is sort of a universal concept on all platforms. So that's another reason you'd want to go with a symbol is to reach a wider audience with your code base in terms of different platforms and binary environments. So there's that as well.
I'm going to say we discussed this in the okay, but however, Gabriel suggests that if they are going to use data only, better to use the newer the newer option, which allows multiple loading. I think that's it.
Both options allow multiple loading.
Okay.
And I did a great job to implement multiple loading even with base modules. So we have that today.
Okay.
Of course, as of version wherever that landed. So, so we have multiple loading both for structures and for special for specially exported functions. It's just that the specially named exported function is much simpler because it doesn't need any sort of features like library constructors. It's just a symbol.
Like library constructors.
Yeah.
And I say you'll take an action to document that.
Sure.
To PR in more documentation. So I'll do a PR that documents the existing, well, not the existing one, but the N-API module register, and if you register the other way, but hopefully we've answered the question in both cases.
Yeah.
Okay, any other discussion, comments on that one? Okay, if not, the SQLite port, I'm guessing, Jim, that you haven't had time since you're away.
I have, in the time since we last spoke, I have moved past the CI issues that I was having. So it is now building on all platforms, but there are random unit tests that are now failing.
Okay.
So progress there, thankfully.
Okay, still moving along. That's good.
Yep.
Okay, and then burning down the list of issues. Are there any particular issues in the repos that we should talk about? I seem to remember there was one.
There's 524 that we were working on last week.
Right, that's the one that I was thinking we should talk about, yes. And I know that, Kevin, you've had some more thoughts. Maybe you can just bring us up to speed on that and we can go from there.
Yes, so last week what we had sort of discussed is we can change the unique pointer just to be a standard pointer. But then we also said that when we were to make a copy, that we wanted to acquire on copy and release on destruct. But what I was sort of thinking is that I feel that we don't necessarily need to implement that logic. Because I feel that, well, I think our reasoning was because that we felt that there was some sort of race condition, from what I recall. But I feel like we would still have that problem if you were using the normal N-API objects, I feel.
Okay, I think I'll try and remember, like I think we thought the case was though that if you're, like we rely on like if you've got an instance of a class, until your class has either called a particular method, it doesn't free that, like it doesn't free the reference count in the API side. But that if we didn't bump the reference counter before the copy, we would potentially have a race condition where that could get fired, but the copy would be like halfway through so that it wouldn't know that it needed to keep it alive for the new copy.
I see.
I don't think that can happen on, it's because the class ends up listening on something, right? And it gets, I forget what, I think, Gabriel, there's some sort of notification, like either you call something saying I no longer need this copy, or you call something and it tells you that, sorry, it's closing, but by the very fact of having called it, it now decrements the reference count and says, okay, well, so don't use it again, right?
Are these are the acquire and release methods that you're referring to?
Well, I don't think it's not that you had to call those, but like I think if you made a call to something, it might tell you closing.
Yeah. So if you, that's the other way of finding out that the TSFN was aborted.
But as soon as you get that closing, does that also?
You are not to call it again.
Right, you're not to call it again, but does that mean that internally it's also basically said, okay, I'm decrementing the reference count because you've been notified?
Basically, correct.
Right. So if that were to happen in the middle of the copy, then you could get into a case where somebody would never have gotten that closing, even though the back end is gone, right? When they called it, I think you would fail.
I don't know if it would be, basically, it may fail to construct the object. That's true, because if let's say one thread is in the middle of the copy constructor and the other thread gets an API closing, now this thread would call acquire, and it would be calling acquire on a thread save function which everybody has already released, and therefore it is not use it. So yeah, that is possible.
So you would need to do the acquire before you did the copy, right? And then you should be okay.
Well, the thing is though, stuff like this shouldn't happen because you know, if you copy the TSFN, then you're doing so for the purpose of starting up a thread, right? But you shouldn't be starting up any threads after they have all released. Otherwise, there's a bug in your code.
Right. Like that's what I'm thinking. I'm saying I feel like the situation should not happen unless there's an issue in your code. Because why would you be copying your thread safe function in a situation where it could possibly have already been released completely? I don't feel like that's not a valid case.
It's the same bug. Exactly. It's the same mistake that you would be committing when using the TSFN directly without any wrapper and calling acquire on it after everybody has already called release. So, so that is a possible coding mistake, yes. And using the wrapper doesn't make it any less of a coding mistake. It's still a coding mistake. Only in the case of the wrapper, it manifests itself as a copy constructor after the last release. And in plain C, it manifests itself as a call to acquire after the last release. Either way, it's a mistake.
Right.
And we cannot prevent that.
Okay, so yeah, if you can't prevent it, then I kind of get the point that it doesn't help.
Right. That's sort of the point that I was making in that previous comment, is that like, just because you're using the wrapper, you would still have that problem if you were not using the wrapper.
Yeah. Yeah, I mean, but this is documented, right? It is documented that once everybody has released it, it is no longer safe to make use of. So it is at that point up to the application to not make use of it. So, you know, we can only go so far.
Right. So is it? Sorry, go ahead.
Well, I was just going to say that there's another thing that we do in our wrapper that I'm not necessarily sure that we need to have, and this check for if the underlying thread safe function exists or not, or rather, if the wrapper holds a N-API TSFN. So there's this error, I guess, if you go to, what is the line? Thread safe to the operator equal. Row. I'm not sure where it is right now. Issues. Let me find it here. Okay, you cannot assign a new TFSN. So line 3990 in N-API inline.
Right.
Yes, so we sort of do this check that the wrapper class, if it already holds a thread safe function that's still alive, we throw this error here. But I feel that if you were not using the wrapper and you tried to call N-API create thread safe function twice, pointing to the same output N-API thread safe function, you would it wouldn't error, would it? It would just, you would just create a new thread safe function. The previous one would just be lost, right?
Right, but that doesn't mean that the wrapper can't be a little safer.
Okay.
Right, like we can't necessarily put code in that says, hey, you're not allowed to sign to this pointer, but in the wrapper we can save you from basically leaking, right?
Makes sense.
Yeah, it can add some value, but then we need a unique pointer because then that makes the pointer that holds the thread safe function itself thread safe, right? Because you know, what if you have like another thread. Well, what if the thread safe function is about to be permanently released, right? Everybody's called release, and it's about to be set to null, right, on a different thread. Holding it like this in a unique pointer was supposed to prevent it from doing the off nominal thing, which is to error when in fact the thread safe function was supposed to be empty. It's just it hasn't reached the thread yet, the information that it is null, right? Like on that thread, it's still not null because it's poised to be set to null. Or the other case where it is already null, and then but the other threads don't know that it's null yet, and so they're going to start using the new thread safe function briefly. So I guess that's what the synchronization here was meant to prevent, if I remember correctly. So yeah, I guess this is value add at this point. It's not merely wrapping.
But I guess it's like that we want to remove the unique pointer, right?
Yeah, in which case we can no longer provide this value.
I mean, is it bad though that, like, what would it be if you? I mean, would it be safer to just say no? You can't reuse a thread safe function.
Yeah, you mean like the C++ object?
Yeah.
Well, yeah, that kind of makes sense.
Because then you could, I mean, then it's easier. The problem's slightly easier, right? You can basically say, sorry, you can't reuse it. We'll throw an error if you reuse it. But you can still copy into an empty one, right? Unless it's that unique. I mean, we thought we didn't need the unique last time. Unless the unique also gives you some, like, when you've copied it and passed it to another thread, it makes sure that it's not null, right? Like that value's actually been flushed.
I don't know. My intuition about this whole thing is that we need to make this class we need to give this class pointer semantics as much as possible, because it refers to a pointer. So if it starts doing stuff on its own, then we are expanding on the tool rather than just exposing it in a C++ friendly fashion. And I don't know. I haven't personally tried to ever write a pointer class in C++ from scratch that behaves exactly like a pointer, because that's what we need here. It needs to be a pointer. Like in the plain C case, an API thread safe function can be passed around by value because it is a pointer, and so the structure it refers to is the same no matter how many copies of it you make, and it is guaranteed to be thread safe because the APIs are thread safe, and that's it. So if we add any APIs at all, then they need to be thread safe. And if we make any storage at all, and we are storing the pointer, then that storage needs to be thread safe. So we are adding value here. We are not merely exposing. And the fact is that even just storing the pointer needs to be done thread safely, because you are now creating two pointers. You're creating a pointer to the C object, and you're creating a pointer to the C++ object. Those are two pointers, and it is your responsibility to manage the access of the C pointer as stored inside the C++ pointer. So in the wrapper we have two pointers. In the core library we only have one pointer. So that's the fundamental distinction between the two, the way it's implemented now.
So here's just a question that I had. Why does the thread safe function wrapper have to hold a pointer to the N-API thread safe function instead of an actual concrete value of a N-API thread safe function?
because the actual structure is managed by an API, and it's allocated internally, and it is freed internally. So it's a NAPI thread safe function was supposed to have the same semantics as a NAPI value. It is an opaque thing that you can copy any number of times, but the life cycle of which you do not manage. And unlike a NAPI value, a NAPI value is understood to sort of become invalid as soon as the stack unwinds. So when your function returns, the NAPI value is gone, right? Because that's just how JavaScript works. If you want to retain something, you need a NAPI ref, right? So you cannot just save a NAPI value in a variable and then just use it asynchronously. That doesn't work. Using a thread safe function asynchronously does work, because that's the whole point of a NAPI thread safe function. So in a way, it's a NAPI ref, really, not a NAPI value, right? But you still, but you still don't manage the lifecycle of it. But like a NAPI ref, you get a notification when it's about to die, right? With finalize, right? And like a NAPI ref, you can delete it explicitly by doing an abort. But unlike a NAPI ref, the effect is not synchronous, because you need to inform all the threads, etc., etc. But basically, you are not in control of the lifecycle of the object. You are merely informed of its lifecycle events, and so we need to encapsulate that, and because we are informed of its lifecycle events, whatever data we store inside whatever wrapper we have, we can manage the lifecycle of that data the same way that the thread safe function lifecycle is managed. So if you allocate data in the constructor of the wrapper, then you can destroy it in finalize, because you know that the thread safe function is about to die. So you're essentially doing an object wrap on the thread safe function with the wrapper. That's how I would look at it.
So, but it's all around. Like I think it's the challenge we're just working through here is how to make them copyable. But the use case is really just copy to pass through a new thread, right?
Basically, yeah.
Yeah, that's
right.
The main.
Yeah.
So can we
basically
Okay, go ahead.
Another use case I can think of is you have like one operation that involves multiple threads in a thread safe function completes, and you have one API for sort of bouncing the operation, like shutting down the operation and then starting a new operation, right? And so you're basically like, okay, the thread safe function has been finalized, right? But the pointer is still there inside your structure, with which you manage these operations. And so now you have a pointer that is stale, essentially, because whatever it's pointing to is no longer there, having completed the operation and having had your previous thread pool all release the thread safe function and everything. And now you wish to assign a new value to it because you wish to fire up another thread pool that is being held together by a new thread safe function. And so you assume that you can reuse that pointer, having been assured that the previous one has been finalized, because you have written your code carefully and you have made sure that you don't overwrite it while the other thread pool is still in operation. And so if the copy constructor fails at that point, then that would be weird at least, and a head scratcher at worst, and then, well, not at worst, but at some worst stage, and just a source of confusion. It doesn't make any sense. Why should you be able to assign the value again? So in terms of implementation, I mean, it seems like a flag might be in order saying, okay, this value can now be reassigned. So the final thing that the finalizer does is to set the value to true, as in yes, you may assign henceforth. Right. And the first thing the constructor does is set the value to false right after a successful call to NAPI create thread safe function, and then it's not copyable in that interval.
What I'm trying to do is see if we can, and I have to go and 2 minutes because I have another call. But what I'm trying to see is if we could limit, rather than trying to, add in functionality and try and have, synchronization and everything to make this thread safe, can we constrain the use case to something that will always be thread safe anyway? So I could see in a case where you copy it to pass to a new thread, when the new thread starts, you should get the current view of the memory, right? Not some old view. So that should be safe without any synchronization, right?
Yes.
Yeah, and
there should be no reason to modify the
right,
state.
right. And then in the case of reusing it, again, you could say that, okay, you can reuse it in the same thread. However, the problem is that you don't know when, like if you said, I'm done with this, you don't actually know when the rest of the threads are finished unless there's real synchronization going on, right? And
Yes,
the
you do.
finalizer is only going to run
Yes,
in
you do.
but it's only going to run in one thread, right?
After all the other threads have said, I will no longer use this. So essentially, let's say we had a Boolean that says finalizer has completed, right? Now, if we have a thread safe, like if we access that Boolean synchronously, and in a with a mutex around it and everything, right?
Then you're good.
Then if you find that it has run, then you're good.
Right, but my point is it worth the mutex to support that use case versus just saying you cannot reuse these?
Okay, but then there are cases when, okay, but how would you do this? How would you do this management of a thread pool which shuts down and then you want to start another thread pool?
Well, just create a new thread safe function. Create a new thread safe function, right?
Yeah, you would, but if you have a larger structure of which the thread safe function is a field, now that field has become dead. You need to recreate the entire structure for that one field, right? Because in a real application, chances are the thread safe function is part of a larger structure, or it's possible that it's part of a larger structure. So now you've basically rendered part of the parent structure read-only.
Right. You'd have to structure it so that you could reuse it. You'd either have to like non-stack, I guess they're stack allocated, right? Which is the one challenge on that front.
We cannot know. We cannot know, right? What allocation mechanism is being used.
Well, I think today there's no new, like they're all on the stack, I thought was part of where we started. Like you can't get the only pointer you can get to one of these is through the ampersand. Okay, unfortunately I do have to go and we're out of time. I can pass on the video if you guys want to continue to discuss. Gabriel, I'll make you the host.
Okay.
Okay.
All right, so I guess we'll talk to you later.
Okay. All right. Well, yeah, I mean, I feel that like we're adding additional complexity to have these features such as this. You can't have a thread safe function overwritten or whatever. I feel like that's just adding additional complexity that we don't necessarily need.
Yeah, I agree. And then, you know, the solution can go one of two ways, right? Either you just overwrite blindly, as we do in the core library, and we leave it up to the application developer to ensure that they are not overriding a thread safe function that is still in use and therefore allowing it to leak. Or we can go the other way, which is what Michael said, which is that once you've used it, once you've created this, you cannot assign to it anymore. right? That's the other possibility. And that one, I don't know. I'm not sure if that's such a good idea, right? Because I think, correct me if I'm wrong, people will simply heap allocate it, and they will check, can I assign to it, or they will just simply free the pointer at that point, because they know that it's safe to free the pointer. So then it'll basically be the same as overriding it at that point. We're just having them go through this extra hoop of forcing heap allocation of the thread safe function, and then deleting it when they know it's safe. So you can override the thread safe function despite all the safeguards, because you just store it, you just get a pointer to it instead, right? And then you manage the pointer, delete the pointer when you know it's safe, right? So in that sense, yeah, just overriding it without any regard for whether it's safe or not, I think is the best we can do anyway, right? Given that people can just go behind our backs anyway. And that's exactly what we do in an API, right? We just override it. Well, you wanted a thread safe function, here's a thread safe function. Where you store it is up to you.
Right. That's how I felt too. It's kind of going back to the earlier discussion that we had. Like with creating the copy before you're doing the release or whatever, like if it's your bad code, the N-API's wrapper is not necessarily going to solve those problems, Yeah,
okay. Exactly. Yeah. I mean, one thing we should be looking at is what will the user's code look like in the end, right? If there's going to be a lot of repetition, something like, if there's going to be like bookends, like you create the thing, then you say X, then you use the thing, and then you say Y, and then you delete the thing, and the X and the Y can be made part of creation and deletion respectively, right? So we say some code that they have to write, but for that we need to know that X and Y is always going to happen, right? And so we can just incorporate them into create the thing and delete the thing, So when we know that is the case, then we can do it, right? That's the only consideration I think that we may want to address with this wrapper, right? No more than that. And basically, the way I think about it is Node.js N-API is a bunch of really, really fancy C macros. That's how I think about it, because it's supposed to be all in line, right? So the things that you would write every single time, you don't need to write them now, because they are being substituted in line by the C++ compiler. That's it, right? So we should not go beyond that, because beyond that, it can be application specific. It may unduly burden simple and potentially performance sensitive applications, and then you need an opt out, etc. So yeah, I agree with you. Like I think we need to simplify this.
Gabriel, could you promote Michael?
Oh yeah. Oh, is he? Wait. Manage participants, attendees. Oh yeah. More promote to panelists. Sorry. Okay, there we are.
Hello. Thanks. Yeah, my meeting was canceled.
Yeah, sorry about that.
Yeah.
Okay, great.
But I think I was listening to the last little bit, and I think I get the point now that the other way to avoid having to worry about thread being out of like non-consistent is just let it be overwritten.
Yeah, I mean that's what we do in core.
The program won't do it if, like, you've got to make sure your program doesn't reuse it until it's ready to be reused. And I guess you're not really reusing it. You're just reusing your copy of the memory, right?
Exactly. Yes. With potential leaks as a consequence if you don't do it carefully.
Right.
But those consequences are application specific.
Right, and it's should be okay as long as you're done with it. It should be okay. As long as, like, I guess the finalizer, that's the finalizer, like in which thread is the finalizer going to be written in? Does it use anything in the class itself?
Well,
right now,
I think the finalizer sets the thing to null, doesn't it? The unique pointer, if I remember correctly.
yeah, that's what I was thinking.
That would make sense.
Yeah, line 191. Yeah.
Sorry, 191?
Yeah.
Correct. Yeah, 191.
Yeah, like basically
Mm.
it shouldn't do that.
Yeah, I mean this makes sense if you wish to enforce this kind of cannot be overwritten. Then this is the place where you would mark the thread safe function as okay. It is now once again safe to accept a core thread safe function value, and this is how you would mark it as being safe, as in it is once more an empty vessel. So yeah, in a way, yeah. I think the unique pointer and this finalizer together, they accomplish this thing where, like, you can't assign to this value if it hasn't been finalized. So okay, that's good. I guess.
Well, another problem that we had, if you remember, was that if you end up making copies, you need to clear the pointer in all of your copies, but the finalizer has already been established to only run on and clear the original objects. Remember how we had that sort of discussion about maybe having some global, or not some global, some like shared object or something. So it seemed like there's
well, wait a second. Like, if you so let's say you're not careful, right? And you so your secondary threads keep using the thread safe function even though the finalizer was called, right? So now all of a sudden, because it's in a unique pointer, right? All of a sudden, you still make like blocking and non-blocking calls in the secondary threads. All of a sudden, the blocking and non-blocking calls would be made against the null thread safe function pointer, because the inside function pointer will have been updated inside the object, right? So so that's going to start erroring out with N-API invalid arg, right? Because it's null now. So that would cause things to break pretty quickly, but potentially in a graceful way, because it is, after all, an API returning an error value rather than a sec fault. So that would be okay-ish, I guess. But still, there should be no, this shouldn't happen, because it's your responsibility to make sure that you don't do that, right?
I guess the other thing too is there going to be any expectation that people believe this finalization will happen for your class versus multiple copies of the class?
Well, no, yeah, that's right. I mean, the finalizer refers to the pointer that is stored in the unique pointer. It doesn't actually delete the instance itself, right? I mean, the finalizer deletes the finalized data. It doesn't delete the instance itself.
Right, but the point is to let the user do some finalization when everything's done, right?
right, do a callback.
Right. Yeah. So now you expect all your copies to, So basically, you expect the finalized to be sort of a fan out that goes to all your copies.
Right, which is not the case, right? Like it's.
Yeah, that would not be the case. Because
Well, okay, although I think the semantics right now are correct, right? Because there is finalization runs only once, right? Up here, like a few lines above the where it gets set to null, it says I finalize that's a callback. So the finalization code gets run exactly once, and then the pointer gets set to null. So all the copies will sort of be gutted after that point, and the finalization call will have run exactly once. So the semantics are correct, right? But it needs to be documented that those are the semantics, right? Like that,
Right. It's not.
that
It's not a
copies,
finalizer
not gonna be
related
copies
to
of the
your.
finalizer.
It's not a finalizer related to the C++ class. It's simply an opportunity to do some finalization once for the TFSN.
Yes, exactly. It's related to the core TSFN. Yeah, it's related to the core TSFN object, not to your instances. That's right.
You can't put you can't subclass, put more
Correct.
data in subclass and then hope that it deletes it for you.
No, you have your finalized data as well as your context that you could use inside of your callback function to do anything specific that you would need.
Right. But it should be not tied to any one of your C++ wrapper instances.
Right.
Yeah, it must not be. So yeah, it's it works, but it needs to be documented that that's how it works, you know.
And then basically remove the dependencies, like trying to set the TFSN to null. Because that's really not gonna happen, right? That would only happen in one thread.
Yeah, but because it's a unique pointer, all the other threads would see that. And
Today,
besides,
yeah.
none of the other threads should even be accessing it, because this finalizer would not have happened unless the other threads had already released it, right? Or been informed of its abortion.
Right, but the point is there that we don't need to check. Like, if nobody can use it, then actually checking whether it's null, we shouldn't be checking, because if you're checking, you're already doing the wrong thing, right? Like if you've called it and it should be null, but it may or may not be null. So why bother check it, right?
It makes sense, yeah. That's true. The if here doesn't make any sense, because exactly, it doesn't make sense. Because it's always going to be non-null, because that's the point you're finalizing it. So therefore it's non-null. And so you set it to null and that's it, and you're done. Yeah, so the interesting thing here is, no, I think that works actually. So when you reassign, you need to create a new core object, and you need to create a new finalizer. But I guess that would be done in the factory method. So you're good there. Okay. Yeah. This is one way of working, I guess.
So it's basically to remove the unique pointer, remove the sort of cleanup of the TFSN, and then just allow it to be directly overwritten.
That's the option. But like I said, or like I'm beginning to realize, the way it is now is just one opinion, basically. Like the opinion is that you are not to override it while it's in progress. And the unique pointer is basically a flag indicating that it is in progress, and doing so thread safely.
But what isn't the problem with the unique pointers that we couldn't create the copy?
Yeah. So that kind of sucks.
Yeah. So then they're like, okay, if we remove the unique pointer, then we can create a copy, because then it's just pointer.
Yeah.
But then if we were creating copies, the finalizer would not be able to really clean up all of the copies pointers. But if we remove that logic that it has to clean up the pointers, then we should be good to go, right?
Yeah. Then we can make copies. Yeah, and then we're passing it around the same way as as we are passing around the core object. So that's the alternative. And
right.
then
And then it has to be
away from.
Sorry, go ahead.
No, you go ahead.
But then it has to be very well documented that the finalizing, again, can't be tied to the, like, you don't get it to fan out to all your copies. It's just one finalization thing, which will happen once on some thread, but don't rely on anything inside the C++ wrapper that's not static.
Yeah, basically.
Yeah, I think that's fair. Yeah.
Yeah,
And
it's a
if you
shallow
add something that's
copy.
static, you may even have to add in your own synchronization, right?
Well, the thread state function gives you synchronization because I mean the thread state function is a synchronization mechanism, right? It's like a really fancy mute, basically, because you know that by the time the finalizer runs, if you've written your code correctly, all your threads will have said, I am no longer making use of that function. So whatever memory they were using, the threads, they will not be using either. So in the finalizer, it is safe to free all the memory used by all the threads because all the threads are gone. You can safely assume that. In fact, in the core documentation, an example is given where the job of the finalizer it is to wait on the threads. So basically, three threads need to be waited on, right, in order for them to clean up. I mean, yes, there is a way to do it without waiting, but you should be waiting on the threads.
Right. I guess that makes sense, but you still need to be careful to only pass the copies to, say, like, new threads. Like, you can't pass a copy to an existing running thread.
I feel like you should be able to.
But if you do, like, so say you subclass, add in your own field, and then you pass it to a new to an already existing running thread, it may not get the right view of that data because no synchronization has taken place.
Yes, that's right. That's right.
Whereas a new thread, you can be sure you're going to get the right view because I think the memory is loaded when you start the thread, right?
Okay, so adding fields to the class is not the mechanism by which you get data into threads with this thread state function. The semantics of the thread state function are a function call, meaning data originates from the thread,
right,
and it wakes up on the main thread, it gets marshaled into JavaScript. The return value there's not even a mechanism for a return value. So it just gets marshaled into JavaScript and that's it. If you want a round trip, you have to use your own synchronization already.
I was just saying that if you for some reason decided to subclass and add some extra data that you wanted to use, you'd have to be very careful.
Absolutely. That goes beyond the scope of this wrapper.
Right. It just needs to be documented to basically say, like, really what you get is something you can use, but in a very careful, like, you're probably safe if you pass it to a new thread. If you pass it to an existing running thread, you might not be safe.
If you add your own fields, you're definitely not safe. But if you just use the APIs here, then you are safe. Because you pass it to a new thread. The new thread is allowed to call acquire. You can even call acquire before you pass it to a new thread, and then the new thread doesn't need to call acquire. And then it needs only call release or properly handle the N-API closing return value, one of those two. And
but for example, you create an instance of it. The TFSN gets set. You pass that to a thread which is already running. I'm not sure you're guaranteed that TFSN, it'll have the right, it may get null instead of what you filled in. Without some sort of memory barriers, right?
But you get null at what location?
Well, it's that if you already, like, because different threads can potentially have different views of the same memory, right? So you create the wrapper. As part of creating the wrapper, you end up with a new TFS function, and that underscore TFSN gets set to a value, right?
Yeah.
If I then pass that pointer, the pointer to that memory to another thread, I don't think it's guaranteed that that TFSN value will have been written. Like, unless you enforce some sort of mutex or what, mutexes have the underlying hardware instructions to say synchronize the memory.
Okay, well, yeah, I guess I am assuming that memory access is synchronous. So if you say like star TSFN equals whatever comes from N-API create, and then you pass it to the thread, then I'm assuming the previous line has completed and
No. Two different threads, there's no guarantees on that front.
No. What I'm saying is, okay. So let's look at it from the point of view of the thread which is about to pass the TSFN to a secondary thread that is already okay. So the first thing the source thread is doing is assigning TSFN to wherever it's supposed to be, right?
Yep.
Next line, it makes a call to the thread. So when the next line executes, the first line must already have completed successfully. Therefore, TSFN must have successfully been written to where it needs to be written.
But only in the cache for the thread, not into real memory. In real memory, it's pending, but because of the multi-level caches, each thread can actually have, like, unless you have the hardware instructions that say, flush my caches so that it's, you see the same thing across threads. I can write to address 1000, and another thread can immediately read from 1000 and get a different value.
Oh, that's sure. That's for sure. Okay,
right.
Well,
that's why I'm saying, like, if you start a new thread, you're probably okay, because I think it doesn't have a cache and it's going to get the current version.
Okay,
right?
no, I see what you're saying. So what you mean is that the secondary thread already has access to the location where the TSFN would be stored.
Yes.
Right? Okay, right. Okay, so I guess what I'm saying is, I guess my assumption here is that the secondary thread will not be accessing that location until it's told by the primary thread, here's the thread save function, right? Because otherwise, like, okay, yes, if you have a secondary thread that is continually polling a certain location, and on the primary thread you write to that location, then the secondary thread may get a partial write and may act on that partial write.
But it's not even the partial write. Like, it's that, things can just stay in the caches until there's something in the processor that says make it so that multiple threads will have the same view. Like, I could write 5 to, say, I've got address 1000. I could write 5. So say there's 6 there. I could write 5 to it. And unless there's some sort of event at the processor level that says, okay, flush that address 1000, other threads will continue to read 6. Right, and, like, on each of the instructions, there's different things. In each of the instruction sets, there's different instructions you can, like, you can do write barriers, read barriers, that basically say, okay, at this point, I want to make sure that everything that's been written is flushed out to memory so that any other thread after this point will read the value. But unless you invoke one of those instructions, there's no guarantee as to what the view of memory from other threads will be. So it's not about concurrent access or anything like that. It's more about, to be fast, the processors have all these caches, which means that different threads can actually see different values for the same address.
Well, I'm not 100%, I'm not really seeing the problem in this scenario where, so say you have one master main thread where you call the create thread safe function, and then that value is now in memory. But then when you say that, now you create a bunch of threads and you pass a copy of the thread safe function, which would just have a copy of the pointer, right, to the underlying N-API thread safe function. So all of your threads that you've created a copy of your wrapper end up pointing to the same N-API thread safe function, correct?
Yeah, what I was saying is if you create new threads, I think you're okay.
Yeah, if you create the thread after, but okay, why are you okay though? Like if we cannot assume that the effects of N-API create thread safe function have safely been stored in memory by the time a new thread fires up, and if we assume that
That's a good point. I'd have to double check whether the creation of a thread has the right read and write barriers. I could be wrong on that.
Yeah, so yeah, that's I mean, if you allocate some memory, you initialize it to a value, and then you create a thread and you pass a pointer to that thread, to that memory, to that thread, then yeah, if the memory hasn't been written by then yes, when the thread starts, it may be accessing the wrong data. That's much certain. I don't believe that's the case. And if that's not the case, then the same thing is true for an already running thread. So like, if I set a location in memory to 1 and then I access it from the same thread, right? If it hasn't been written to memory yet, then from the same thread, it will also not be 1, right? Because when I dereference a pointer in the same thread, I am saying go to that memory location and fetch that thing, right?
Within a thread, you're always good, because
but why?
The way the caching works is that in a thread you are
I
guaranteed
see.
to get the same view because you're using the same caches,
Yeah,
right?
okay.
So within
Okay,
a single thread, you're good.
translate.
It's just that across threads, you need to have either a mutex or something, because in those mutexes, they basically say, okay, I'm going to invoke the barriers which will ensure the same view across the different threads.
So then basically you should be using an atomic, or you should be like an atomic test set.
That's one of those things. Yeah, like those will likely have barriers of some sort. We'd have to look at exactly the right barriers to see which ones they are. Let's see.
Yeah. But honestly, I've never run into this before, like where you just allocate something and then you pass the pointer to a thread and the thread doesn't have it.
It's that you'll get the wrong thing.
Yeah. So like, like new int 5 and then pass the pointer to the thread and then the thread will read 6.
Just reading the.
Oh, wait a second. What are we talking about here? So the way you start a new well, yeah, okay, but we're not talking about a new thread. We're talking about an existing thread. Okay, never mind.
Right, I was saying, like with a new thread, I was thinking that there'd probably be some barriers in there.
Yeah, because you pass the pointer to the new thread, and so the wrapper around the starting point of the thread will ensure that the memory has been flushed before it actually starts the thread.
That's kind of what I'm thinking, like, especially if, like, because otherwise, yeah, that was my guess, that thread start will actually, say, okay, well, if we're doing that, let's flush and make everything consistent. Whereas if you somehow pass it to an already running thread, there's a much, there isn't going to be necessarily anything which enforces
Well,
the concurrency or memory consistency.
okay, but when you have when you have an already running thread, right? Then all the mechanisms by which you pass anything from the main thread into the already running thread are mechanisms under your control, right? Because and this is actually one of the primary use cases of a thread safe function, right? Is where you already have a threading implementation, and you just need to inform JavaScript that something has happened, right? And you don't wish to rewrite your threading implementation to use async because or async worker because that uses a thread pool. You have no control over the threads, right? So that was the original motivation behind thread safe function. So because you have an existing threading implementation, you also have a mechanism to pass things between threads, which presumably is thread safe. And so the value that you pass into your existing custom thread pool now is the thread safe function, right? So how does that happen? You create the thread safe function, and then you pass it into your thread using a thread safe mechanism that you've been using so far, but for different kinds of things, right? And so because it's thread safe, because the mechanism by which you pass the pointer into your already existing threading implementation is thread safe, therefore, when the value arrives on the other thread and the other thread consults the value, it will have been correctly written. So you also have to look at it in terms of the use case, right? Like where you already have a threading implementation. That's why you're using thread safe function to begin with.
I guess maybe we'd have to just make sure to say it's up to you to make sure that you're going to have a concurrent view, a consistent view of the thread safe class if you pass it to another thread, which maybe is obvious, but.
Yeah, I think that would be a fair assumption.
Okay, so I think that's at least something, yeah. So that's probably. So in which case, I mean, as long, yeah, if we basically say it's up to you to make sure that there's consistent, memory consistency of the thread safe function is managed, then you can reuse. You could pass it to an existing thread as well.
So then is the approach that we want to take is changing to a regular pointer and removing the pointer checks and assignment? Or?
Yeah.
Okay. All right, I can work on that, I think.
Speaking of all these already running threads, one, if you're working on this, then one of the tests you might want to add is what we just talked about, where you just fire up a bunch of threads, let them run for 5 seconds, and then pass the thread safe function and start the work. Because right now I think the only test we have is in comes the request from JavaScript. You create the thread safe function, you start the threads with the thread safe function as the entry point void star, right? And then work on it. They report back and they quit. So one test that would be really good would be, yes, you fire up all the threading machinery and they just churn, run idle in a loop, or not idle, but they run busy in a loop, and then you pass in the thread safe function. So that will probably be something like create a thread safe function and then signal a condition variable, and the threads will then watch for the condition, and then when the condition is true, they would pick up the value and do whatever they do now, only after the fact. And you may even leave them running for a little bit after they're done. So maybe after, but I guess that's kind of pointless, because if you write it correctly, which is, they release the thread safe function, or they are after closing, then if you put an idle, or if you put a busy loop after that fact that runs for 10 seconds, it doesn't matter, right? Because it's just going to take 10 seconds for the finalizer to join the threads. Nothing else is going to happen for 10 seconds. That's interesting. So that part is not that important, but the already running thread part might be worth testing for, to make sure that we have.
All right.
Yeah, and certainly some things like those con variables and stuff will often put in the barriers that you need to synchronize anyway. So, but
all right.
But see, that's just it, right? Like the condition variable is in a different location than the data, right? So just because I signal the condition that I have written the data on this thread, if it is, as you say, that it may not have been flushed to memory, then signaling the condition, the condition is not associated with a pointer, or is it? Wait, let me check.
No, I mean, but those operations are very expensive in that they don't flush like a particular address; they flush everything.
Oh, I see. Okay, so basically, if you have a condition variable between two threads, it's a signal to the processor to basically validate the entire cache to make sure everything is flushed.
Yeah, like I don't know condition variables specifically, but like if you use a mutex, part of what is done is often in the mutex is to say, okay, I'm going to flush everything so that when you release and I acquire, I'm going to get the mutex that I've say I've guarded the update of a particular count, that when the next guy gets the mutex, he sees the right value of the count.
Okay, all right, but what that means, correct me if I'm wrong, is that the entire memory that is accessible by the entire process pretty much gets flushed at that point.
The caches get flushed.
Yeah. Everything that's in cache, gets sort of committed.
Yeah, exactly.
Because the implementation of the mutex cannot know what the critical section is going to end up accessing, so it has to flush everything.
Yeah. And that's where, like, instead of doing a mutex, that sometimes there's like instructions to do an atomic increment or something, right? And those may be more targeted.
Yeah.
But yeah, I guess, I mean, anyway, I think we've come back to, if you're writing multiple threads and coordinating, you've already got to worry about that. So we just should be clear that you've got
to worry. That's right.
The thread safe function isn't solving that problem for you at all. You still need to worry about that for any data that you're relying on.
Yeah, exactly. That's right. So any shared data between two threads that is not read-only needs to be synchronized, including including assignment of the newly created thread safe function. That also
exactly. Like I could just see, like, somebody might have assumed that because it's buried inside the thread safe function, they didn't have to worry about that. But it's like if you make a copy of the threads, if you pass the thread safe function to another thread, it has internal state. So you better make sure that whatever you're doing ensures memory consistency for that.
That's true. Yeah, that's true. Yeah, so I guess what, in a way, what we're talking about is sort of buried in the expression we're using, because we're saying when you pass the value to another thread, well, passing a value to another thread involves exactly the kind of flushing of caches and all that that we just talked about, right?
Yep.
So
yeah, exactly.
So it is kind of solved, because there is the only other way to pass to another thread is to as you said, just write it in memory, and the other thread just keeps polling and polling and polling. And is that null? Is that null? Is that null? Is that null? That's a really poor way of synchronization.
Well, yeah, no, that wouldn't work unless you did unless you use some of the right instructions anyway.
Yeah, exactly. So
like an atomic compare and swap might work, but only on for the value in that you've atomically swapped, not what it points to.
Yeah, exactly. Yeah, so you'd kind of not want to do that, because although the pointer value is correct, the memory may not be. Yeah.
Exactly. Right. Like you might, if you actually want a pointer to memory, you should just do a like a mutex or a con variable or something.
Yeah.
Yeah.
Yep.
Okay, but I think, yeah, we're back to, it's if anything, we should have some reminder in the documentation that it applies to the thread safe function as well as everything else.
Okay.
And I don't think it changes anything that Kevin was asking. So.
Oh geez, where am I? Oh, wait.
No, I think that's all makes sense to me.
Okay, sounds good. Okay, talk to y'all next time.
All righty.
Okay, thanks. Bye.
All right.
All right. Talk to y'all later.